In this video, we are going to determine the net electrostatic force of a charge when the other charges are affecting it at the points of a right-angled triangle. But before we do that, let's discuss a force in more detail. As you will recall, a force is either a push or a pull. A force is also a vector. Okay, and so we're going to take all three of these ideas and revise how to add forces in a head to tail fashion. So if you have F1 acting on an object, something is pulling it upwards, and another force is pulling it towards the right, and let's call this force F2. If I want to calculate what is the net force going to be on this object here, I can add these two vectors by placing the head of the one vector at the tail of the other. So let's move F2 to the left. And now I have my two vectors where the head of the one force is touching the tail of the other one. And to calculate my net force, I'm going to draw my vector from the tail of the one to the head of the other one, and that will be my net force. And the angle here will be theta. Now this is a right angle triangle, and we add right angle triangles by using Pythagoras Theorem. That is to say that f net squared is the sum of the squares of f1 and f2. So this is Pythagoras Theorem. If I want to calculate theta, I'm going to say that tan theta is opposite over adjacent, which is from maths, but in this particular situation, it will be f1 divided by f2, and then you solve for theta using the inverse function on your calculator. Here we have a situation where we have three charges that are placed at the vertices of a right angle triangle. And when you have a situation like this, you might be asked to calculate the net force that charge Q1 or the charge in the corner is experiencing. When this happens, there are 5 things you need to do. And the first thing is that you need to establish the signs so that you can figure out what direction the forces are going in. So for example, in our first scenario, let's say Q1 is a negative charge. And let's take Q2 to be positive, and let's take Q3 to also be positive. So now you know that opposite charges attract. And with the second thing we have to do is to draw a free body diagram based on this attraction and repulsion. So let's reduce Q1 to a dot. In a free body diagram, you always reduce your object in that you are focusing on to a dot. And then the forces are going to be pointing away from that object. So let's figure out what is the force that Q2 has on Q1. So because they are opposite, it's going to be an attraction force. And so Q2 is going to pull Q1 towards the right. Therefore, the force vector of Q2 on Q1 will look like this. That is the force of Q2. And similarly, Q3 is also going to be pulling Q1 towards itself because this is negative, this is positive, and opposite charges attract. And so that vector is going to look like this. F due to Q3. And so now we have our two vectors. And now we're going to add them using Pythagoras. And that's how you will calculate the net force. And theta will be so many degrees using tan theta away from the positive x-axis. And then if you don't have these forces, you simply have to use Coulomb's law. And then the charges that you want to use and substitute into Coulomb's law will be the charges between which you are calculating the force. So it will be the charge of Q1 and the charge of Q2. And this one will be the charge of Q3 and the charge of Q1 over R squared. So it will be the force between these charges. So if you don't have these forces, you use Coulomb's law separately, and then you add them using Pythagoras, and then to calculate theta, which is the direction away from the x-axis, or the angle away from the x-axis, you're going to use tan theta is equal to the magnitude of this divided by the magnitude of the adjacent